Okay, so today's topic is internal resistance. Internal resistance is basically resistance of a cell or a battery or a voltage source like generator, etc. So, what is internal resistance? Internal resistance is the resistance within the voltage source, and voltage source can be cell and battery that causes heating effect or voltage loss or power loss within the battery is known as internal resistance. So, internal resistance is basically the resistance that is inside the voltage source. So, if we talk about its symbol, it is like this. So, this is the symbol for the cell. This is positive terminal, this is negative, and then here is the symbol like resistor, and small r is there, and then a dotted box is usually over there. That is indication that this whole thing is a cell or battery. So this is how we draw the symbol for internal resistance. So it is R, small r, which is inside the cell, and cell is having EMF of E. Okay, next thing is what is its reason? Why internal resistance is there? Why resistance is there inside cell? Because the work of cell is to provide energy to the charges. But the thing is, this cell is made up of something, and we say that material of cell causes internal resistance. So let's say what type of material can be there within the cell. So we can say that if it is a dry cell, then the chemicals are there, or lead is there. Chemicals are lead. So the resistance is due to these chemicals or lead. And if we say that it is a acid battery, like the liquid battery, then uh, the plates of the battery, the metal plates inside the battery, those have the resistance. So due to that resistance, the battery is having the internal resistance. Okay, so um, what is the effect of internal resistance? Its effect. Its effect is it lowers the efficiency of cell, or it means that less output voltage. Less output voltage means that if a cell is having a EMF of 9 volt, but the voltage that it can give out to the other resistors which are in the circuit, it should be less than 9, or they should be less than 9. Less than 9, like they can be 8.5 volt, they can be 8 volt. So where are the other 0.5 volts or 1 volt? Those are lost against the internal resistance. So if we now draw its circuit symbol, so the circuit symbol is like this is internal resistance, this is EMF of the cell, and then here we connect a milliammeter or ammeter, and here is a resistor. We can connect a variable resistor over there, and then we can connect a voltmeter across it as well. You know that this voltmeter tells you potential difference. This tells you how much is the current in the circuit, and this is called output potential difference across this resistor R. So the equation for this circuit is, we know that voltage conservation law is that input voltage is equal to output voltage. Like this is the general rule के बैटरी की जितनी ईएमएफ होगी सर्किट के अंदर उतने ही पोटेंशियल डिफरेंस भी होगा. सो वी से कि इनपुट इज द ईएमएफ ऑफ द बैटरी, सो इट इज ई, एंड द आउटपुट देयर आर टू टाइप्स ऑफ द वोल्टेज. वन इज this which is across this resistor, and the second one is the voltage loss across this internal resistance. And how that works, because when the current is coming from here and when this current flows through this resistor, then it dissipates energy, and that is called the potential difference. And then it goes from here, and when current goes through the internal resistance, then it again dissipates energy, so that is called the lost voltage. So it means that there are two type of voltages. One is useful output voltage, plus other one is lost voltage. This you must have studied in work power energy as well, efficiency. That in efficiency of any system, there is always one input, there are always useful output, and there are always wasted. So it is the same. This is the input, and this is the useful output, and this is the wasted. So we say EMF is equal to useful voltage is IR and lost voltage is I small r. Why? Because we know that the useful voltage V out is equal to IR. I is the current and R is the external resistor. This is also called terminal potential difference, TPD, terminal potential difference. And then the lost voltage is I small r. This is lost inside the cell. These voltage are lost inside the cell. Okay, so this is the equation. What you can do is you can take I common. Why I is common? Because this is series circuit. And we know that we can say that I is same. Why? Because this is series circuit. Since R and small r are in series. That's why we say that this is a series circuit. Okay. So this is our main equation that we are going to use. Let me tell you a very simple example to just to apply this equation. Let's say we have a cell, we have internal resistance, and then we have two external resistors over there. This cell is 3 volt, internal resistance is 2 ohm, this is 6 ohm, and this is 8 ohm. Now, what you have to do is you have to find how much is the total resistance, how much is the total current, how much is the useful output voltage, how much is the lost voltage, and how much is the efficiency of this cell. Can you try solving this question? Okay, so if you have solved, so you can just check these answers. So these are the answers for this. Lost voltage is 0.38. Now the last thing is okay, you have to find the efficiency of this cell. We know that efficiency is equal to useful output over total input multiplied by 100. So useful output here is 2.63, and you have to see total input is 3 multiplied by 100, and you will work out for its efficiency, which will be 87.7%. So this is how you can find efficiency of the cell. Okay. So we just have learned the definition of internal resistance, its symbol, then its formula, and how you can apply its formula. Now we have to look for one more thing, which is maximum output power by battery. And we have to look for the condition in which that battery will give you, a battery with internal resistance can give you the maximum output power. वो कौन सी कंडीशन होगी जिसमें कोई भी बैटरी जिसके अंदर इंटरनल रेजिस्टेंस लगी हुई है वो आपको मैक्सिमम आउटपुट पावर दे. तो उसकी जो फिक्स कंडीशन है वो ये है कि when internal resistance and external resistor become equal in one circuit, the external and internal resistance become equal, then battery produces maximum output power. So when internal and external resistors are equal, then you get the output power by battery will be maximum. In order to prove this, again, we are going to look upon an example. There is a cell which is having internal resistance of 10 ohm and the EMF is 3 volt. The external resistor that we have connected is variable and we can change its value between 5 ohm, 10 ohm and 15 ohm. So we can set it 3 values for this. So what you will be doing is, what will be your task? We say that if external resistor is 5 ohm, then you will have to find how much is the total resistance, how much is the current flowing, how much is the useful output voltage, how much is the lost voltage, how much is the power input, which is power produced, and how much is the power output, which is across external resistor. And similarly, you will do it for the others too. Like first I'll be doing for 5 and you will be doing for 10 and 15. So let me first do it for 5. If this is 5, so total resistance, these two are in series. So 5 plus 10, 15. So total resistance is 15. Current is equal to V over R. So we say that V is how much? 3 and R is how much? 15. So 3 over 15 is 0.2 ampere. So the current is 0.2 ampere. For the useful output voltage, we know that it is IR. I is 0.2 and R is 5. So 0.2 into 5 is 1 volt. It means 1 volt will be only the output voltage. Last voltage is of course EMF minus V out. So EMF is 3, V out is 1. So it means 2 volts are lost. Input power. Input power is the power produced by cell, which is IV. I is how much? 0.2. V is battery EMF. So battery EMF is 3 volts. So it is 0.6 watt that the cell is producing. What is the output power? It means the power dissipated across the resistor, that is IV. I is 0.2 and V is the voltage across the output resistor, which in this case is this, which is 1 volt. So we'll multiply by 1, so it is 0.2 watt. It means that the battery is producing a power of 0.6, but only 0.2 is appearing at the output. The rest of the 0.4 is lost. So 0.6 is produced and 0.2 is appearing at the output and the rest of 0.4 is lost. So we have to find lost voltage. So we say, sorry, it's lost, not lost volt, but lost power. So we say find the input power and then find output power, subtract them, Input was 0.6, output was 0.2. It means 0.4 watt is lost. Now you have to do the same thing by keeping the resistance 10 and next keeping the resistance as 15.